Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you a couple of ways to deal with missing values in your data frame. So first I am going to use this URL, this data frame right here, and then at the end I will show you something else using this data frame. But first let's go ahead and start with this. Let's go ahead and import pandas as PD. And then let's do df equal to pd.read csv. And let's start with URL, which is the first one. So let's do df.head and get a preview of our data frame. So if we go ahead and look at this data frame right from the get-go, you can see NaN here. You can see missing values in this data frame. Now, how do you know actually how many missing values you have in each column? To do that is very simple. We just do df.isNull.sum. So basically it gives you the sum, the total of how many missing values are in each column in your data frame. As you can see, like here, the blank column is only has nothing but missing values. So because the blank column has nothing but missing values, if this was an actual data set you're working with, it is safe for you to just drop this column right here because it doesn't add any value. So we'll do df equal to df.drop, and then we say columns is equal to blank. Then we can go ahead and do df.head. And now as you can see, the blank column is gone, it's no longer here. And then we can look at other columns. So if we go ahead and do df.isNull, if you just do .isNull without putting .sum, it returns false, 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 true, So this is not what we want. We want to get the total missing values. So now the blank column is gone. Okay, and as you can see here, the number 7, also 50% of the values here is missing. To deal with missing values, there's a couple of techniques you could use. Of course, you could drop something like a column that's not useful or a bunch of rows that's not useful. So like I said earlier, we have almost 50% of everything in the number 7 column is missing. So originally, let's do length of df. Original data frame is about 1,000 rows. If we drop 513 rows from number 7, we are going to have like 417 rows. Okay, so I'm gonna show you how to drop rows of missing values if that's something you want to do. So to do it, we do df equal to df.dropna, and then in parentheses we do subset is equal to, here you can put in multiple data frames, like multiple columns like number 7, then you do something like boolean 2, if you wanted to include multiple columns. But in this case, I just want to drop from the number 7 column. So make sure you put number 7 in a list format like this. If you just, let me show you. If you just do it without having the list bracket, it's going to throw an error. So with that being said, let's go ahead and do df.head. As you can see, we still have the number 7 column, but now let's do length of df. As you can see, our columns, our rows is now 487. So we started with 1,000 rows, but then we dropped 513 missing values from the column 7. And now we are left with 487 rows. Now let's find out how many missing values we have. So we just repeat what we've been doing here. So as you can see here, we still have some missing values. So in the num column, num5, num8, year, boolean 2, we still have missing values. But in the number 7 column, we don't have any more missing values. That's because we dropped all of it. So this is another technique for dealing with your missing values. You can drop a whole column that's useless. You can drop row wise. We can also just drop missing values from the entire data set. So I'm gonna set this to a new variable, df2, and then we're just gonna do df.dropna, and we are gonna run this, and then we do df2.head. As you can see, we still have data, and now we are gonna do length of df2. So now our data frame is down to 152 rows, and we can do something like df2.isNull dot sum. As you can see from all our columns right here, we do not have any more missing values. So if you wanted to, you could drop all the missing values at once. But dropping your missing values is not always the most efficient way to deal with missing values. So let's go ahead and look at pandas. So pandas has a function called fillna. All right, fillna basically allows you to fill in your missing values. There's different method that you could use. You could use backfill or bfill, pad, or front fill, or none. And the default is none. And here it tells you the value that you use to do the filling. So if I go ahead and do df.head again, you can see that we still have some missing values here. And you can do this for like in the entire data frame. You can use fillna for the entire data frame, or you can do it per column. So first I'm gonna do it for the whole data frame so you see what it looks like. And then I'm gonna do it column wise. So let's say we do df3, and we say df3 is equal to df.fillna, and then let's just put in 700. Okay, so basically it's going to replace all the missing values with 700. So now if we do df3.head, as you can see, all the missing values has been replaced with the value 700. And the cool thing is that even for boolean values, or even for like categorical values like city, right here, it took the 700 and the 700 is recognized as a string, as opposed to in places like number where it's recognized as a float. We can double check this by doing df3.dtypes. As you can see here, city, boolean, and city2 are all objects, but everything else is a float. And then when we did our fillna with 700, this 700 is considered a number. It's considered a number, but this 700 is treated as a string. So that's a pretty cool technique. So we can also use a dictionary to fill our na. So we can do something like df4 is equal to df.fillna, and then we provide a dictionary, and then we want to say for the num column, we want to fill it with the value 900. Okay, for example. And then for let me see, what else do we have missing values? We have missing values num5, and let's just do city. So we can do for the num5 column, we want to fill it with 400. And then for the city column, we want to fill it with Seattle. Okay. Now, if we go ahead and do df4.head, as you can see right here, the missing value in num column has been replaced with 900. The missing value in num5 has been replaced with 400. And these other ones, like something like year 2, still has their missing values. And in city, the missing value has been replaced with Seattle. You could also use the mean. So here I could change this to df num dot mean. Okay. So now the missing value in this particular column has been replaced with the mean of this column. And everything else basically stays the same because I didn't change it. So this is one technique for filling missing values in the entire data frame at once. If you wanted to do that, you could use the mean. And another technique is by doing backwards filling. So if I go ahead and do df.head and I want to preview the first 20. So here we see a lot of missing values like in this situation. So I'm gonna use let's say Boolean for example for this first one. So what I'm gonna do here is I'm gonna do df I said Boolean is equal to df Boolean dot fillna, and then I want the method to be equal to backfill. So if you look at this here, we can type out backfill or we can do bfill. So I'm just gonna do bfill, and this is for the Boolean column. Okay, and backfill is taking something like true value and replacing our NaN with this. So it's gonna fill backwards, or yeah, taking from true and replacing NaN with true is backfilling, and forward filling is like it's a taking true here and replacing this with true. That's forward filling. Let's go ahead and run this. As you can see right here, it worked despite this one right here. So originally, before I did this, right, our Boolean right here had NaN and it had true. It had NaN here and had true. Okay, and for example, and then when I did this method of filling it, it replaced that NaN with true. So it took from here and moved it forward. That's backwards filling technique. And you could also do this for the whole data frame if you wanted to, but I wanted to use a single column to showcase how this really works. And if I do df20 and we scroll down, we can, as you can see, all those NaNs has been replaced with true because of backwards filling. Now I'm gonna do forward filling, and let's use Boolean 2 as an example. And basically what's gonna happen is like this NaN is gonna take this true value will replace this NaN value, and then this false value will replace the next two NaN values. And also down here, this false value will replace these two NaN values. So this is forward filling technique. And I'm going to show you that in a minute. And let's just change this to Boolean 2. df.head. And as you can see right here, those things has been replaced. Let's look at the first 20. And if you're looking at Boolean 2 right here, as you can see, right, those two NaN, so we had two NaN right here. They've been replaced with false, so forward filling. This was used to fill in these two missing values. And also false right here was used to replace these two missing values. So basically, that's how backwards filling and forward filling methods work. And like I said earlier, you could replace something with the mode, that is like the most common item in it. So for example, for the year 2 column right here, I could replace the missing values with the year that occurs the most often. Of course, this is not recognized as a year. This right here is recognized as a float. If I wanted to, I could change it, but that's a different video. But for this one, the year that occurs the most often is what I'm going to be using to fill these two missing values. And again, you use the same technique. Here, what's the column name? Year 2. And here I'm gonna say value is equal to. And before I say the value, I'm gonna do import statistics. I'm gonna do import statistics, and then I'm gonna do statistics.mode, and then in parentheses I put in df year 2. Let's run this. Here, let's remove this and run this. All right, now let's do df.head. So basically right here for the year 2 column, right, the mode for this column has been used to replace the missing values. If I go ahead and copy this code, as you can see, 2008 is the mode, that is the value that occurs the most often. And if you look at 20 here, as you can see right here, for year 2 column, all the missing values has been replaced with 2008. There are no more missing values in year 2. So that is a couple of techniques for dealing with missing values. You can replace the missing values in a column using like something like the mean of that column, the median, the average for that column, the mode, the thing that occurs the most. You can drop columns completely if you need to. You can drop rows completely if you need to. You can do forward filling, which is taking this and putting it onto the next item. In this situation, to be like taking 2012 and replacing this NAN 2012. You could do backwards filling, and if you do backwards filling, you take 2004 and replace NAN with 2004. That's backwards filling. There's different techniques that you could use to deal with missing values. But whenever you're dealing with missing values, I highly encourage you to use common sense. And I'm going to show you what I mean here by common sense. So I'm going to call this test equal to pd.read_csv. And I'm going to be reading the second URL that I had here. Test.head. So in this situation, right, this is a life expectancy data set, and this is like for every single country, the year and the status and their life expectancy, and these are the factors that affect their life expectancy. Let's go ahead and see how many missing values are here. So if you look at this, you can see that in the life expectancy column, we have about 10 missing values. Adult mortality, we have alcohol, hepatitis B, so total expenditure, HIV population, so it's like we have a lot of missing values in this data frame. Now in this data frame, okay, because of the type of data it doesn't make sense to fill the missing values with anything. This is what I mean. This life expectancy data is for like different countries. If you do forward filling in this, then you'll be taking data from a different country and putting it in a different country. Okay, if you do forward filling in alcohol, then you end up using the alcohol consumption information for a different country and imputing it for alcohol consumption information for a different country, and that is going to drastically impact your model. Like that's gonna basically destroy your whole model. Like what's the point of even doing a model if you're going to use garbage data, right? So we know what they say, garbage in, garbage out. If let's say you take the hepatitis B information for one country and distribute it across all the countries, then you are manipulating your data. You are making your data unclean. Basically, you are dirtying your data. You are like adding dirt to your data, so your data is no longer clean. Your data is no longer pure. Your data is no longer useful actually, because let's say for example, right, this one, if you take the GDP information, like let's say if you take the average GDP information and input it for the GDP of missing countries, well, guess what? Your data is no longer clean. You have badly manipulated your data, because the average GDP for all the countries is not an indication of a country's GDP if their GDP is missing from this data frame. So basically, whenever you're dealing with missing values, what I'm trying to say is like kind of use common sense. In this situation, in this data frame, filling the missing values it's not going to be good. It's going to be really, really bad, because you're manipulating the data in a bad way, and you're not going to have an accurate model, because you're going to end up using garbage data for your model. So in this situation, the best option is probably to drop all the missing values, just to keep your data as pure as possible. So if I go ahead and do length of my test data frame here, as you can see, it's about 3,000 columns. And what I'm gonna do right here is just drop the missing values. Even after dropping the missing values, I should still have enough data for like to do whatever. So in this case, I'm just gonna do test is equal to test.dropna, and I'm just gonna leave it as it is, and then do this again. As you can see right here, we no longer have any missing values. But let me see, how much data do we actually have now? So we can do length of test again. And we cut our data pretty much in half. Like by taking out all the missing values, we cut our data in half. Something else we could do, instead of, let's say, dropping missing values for everything, we could drop the missing values for the things that we're missing the most values in. So, for example, in population, in GDP, and in hepatitis B, that's where we have the majority of the missing values. So we can just drop drop missing values from those three columns only, and we'll still have plenty of data left. So here we do test is equal to test.dropna, and then we do subset is equal to, we put it in a list, and we also wanted to do population. If we go ahead and let's say do this again, as you can see, we still have some missing values in those other columns, but the missing values from GDP, population, and hepatitis B is gone. We've dropped those rows. And if we go ahead and get the length of our test again, as you can see, we have a little bit more data than we had last time. When we dropped everything, we ended up with about 1650 rows. That's when we just dropped the columns that has the most missing values. We have about 150 rows more. Well, less than 150, but 140 rows more. That's basically in a nutshell. That is like one technique, or that is some techniques for dealing with missing values. You can drop rows, you can drop columns, you can fill the missing values with the mode or the mean or the average. You can do backwards filling, you can do front filling. And just thinking about it, I could have just done instead of doing this, I could have done df2 dot mode. Yeah, that worked. So you can, instead of importing statistics and using the statistics module, you could have used the pandas built-in module. Yeah, it still works. So, and if I do this right here, it gives me the value 2008. So yeah, I could have used the Python mode function. I didn't think of it back then. I just thought of it. This also works as well. This gives us the same information. That's basically it for this video. Thank you for watching. If you like it, please give it a thumbs up and subscribe to the channel. If you made it this far in this video but you didn't like it, please give it a double thumbs down and still subscribe to the channel. To get access to this notebook that I use in today's video, just go to machinelearningeducation.com, and once you are here, you can click on free data science resources and you'll be able to get access to this page. This is where I keep my data science tutorial notebooks. I create a lot of YouTube videos and a lot of blogs, and I end up with a lot of notebooks. And I just find it easy and straightforward to take all my data science tutorial notebooks and put them under one platform. And that is at machinelearningeducation.com/free to get access to the notebook that I use in today's video. And you can also find me online at evidencen.com. This is where I have my data science blog posts. And as time goes by, I'll create more and more stuff and add it to my data science blog post. And once you are here at evidencen.com, you can also click on free data science resources and you'll be able to get access to this page. Thank you for watching, and I'll talk to you on the next one. Bye.